very hearty good evening to all the participants of the Center of Excellence in Safety Engineering and Analytics. IIT Kharagpur welcomes all the participants to this 19th Weekend Talk. And this program is conducted under Azadi Ka Amrit Mahotsav, which commemorates 75 years of India's independence. So, as usual, we start this session with a beautiful sloka. Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amritam Gamaya, which inspires us to lead from ignorance to the truth, from darkness to the light, and from death to immortality. With this, myself, Mom Mitra, along with Sinjana, Sovik, and Ashish, will moderate this Weekend Talk, week 19. So, we would like to invite the dignitaries on the virtual dais. And I would request Professor Maiti, Professor Obi Krishna, and we have Prabal sir with us to unmute their videos to come to the virtual dais. So, ladies and gentlemen, today we have a very interesting and fruitful topic, role of smart safety management in improving maintenance effectiveness at Tata Steel. So Mr. Prabal Ghosh, he's working as a Vice President Shared Services in Tata Steel Limited and is responsible for asset, utilities and infrastructure management of the 10 million ton integrated steel works at Jamshedpur. Over the past years, he has worked in operation and maintenance, capital projects execution, and also got exposure to TQM at JUSE, the Japanese Union of Scientists and Engineers of Japan. He has completed Executive General Management course from CEDEP in CEAT campus at Fontainebleau, France. He also attended Global Advanced Management Program organized by All India Management Association in Silicon Valley. He has served at different capacities in mechanical maintenance functions and executed various upgradation projects in wire rod mill, hot strip mill, and cold rolling mill. So as a project manager, he has experience of implementation of a joint venture capital project of continuous annealing and processing line with Nippon Steel Corporation of Messrs. JCAP CPL. During his previous tenure as Chief of Mechanical Maintenance of Tata Steel Jamshedpur Works, he had worked extensively in establishing advanced conditioning diagnostic techniques, reliability-centered maintenance practices, and driving smart asset management system, leveraging asset digitalization, and setting up asset monitoring and diagnostic center for implementation of predictive analytics-based maintenance strategy. So, ladies and gentlemen, we look forward for a very, very fruitful and useful session today. So I request Professor Maiti to to formally welcome our expert speaker.
Thank you, Mom. Thank you, Mr. Ghosh, for your kindness. And already Mom said about Mr. Ghosh, and I just want to tell a few of them. First of all, I found the topic. So the role of smart safety management in improving maintenance effectiveness at Tata Steel. Usually we understand that maintenance effectiveness improves safety, but this is another the different way of looking into safety management. That means smart safety management improves maintenance effectiveness. This basically the title. I think that it's a innovative title, and all of us will be really tremendously benefited today. And regarding Mr. Ghosh, after reading the biodata and also knowing from Professor Krishna that starting from asset management, operations maintenance to asset digitalization to predictive maintenance, and also including TQM. So in almost all the areas related to plant operation, maintenance, and plant management, he is an expert. And we are really fortunate enough to listen from such an expert who will cross-connect with many other aspects which are also influencing safety. So with this brief introduction, I welcome Mr. Ghosh to this CoE-SEA Weekend Talk. And you, Mr. Ghosh, it is a center with a lot of hope, and your predictive and diagnostic that management center where basically the predictive maintenance you all are doing there are a lot of similarity with our work. Our machine learning and AI group working on predictive safety management, predictive analytics also. And I'm sure with your current today's talk and with your help, CoE-SEA will be definitely will be able to reach to the level with your support and cooperation. Thank you, Mr. Ghosh.
Yeah. Can I begin? Mo?
Yes, sir.
Okay. So, good evening, all of you who are present today in this session. I would like to thank, first of all, Mom for taking the whole, the briefings, entire profile so deep. I don't know how much is it, but nevertheless, thank you for that. Professor Maiti, Professor Robi Krishna, Mr. Andrew Page, who have extensively worked in the entire safety excellence journey in Tata Steel, and we have been very closely associated. All my colleagues from the Center of Excellence, Safety Excellence Center at IIT Kharagpur, and all participants. First of all, it has been a great opportunity. I'm highly honored to talk on this subject. Of course, fundamentally, we always believe that good maintenance will improve the safety. At the same time, I think if we are able to design safety well in our equipments or the processes, and able to engineer it fundamentally, then it always helps to do maintenance more effectively in a much more better way. And as I've been driving the asset management framework for the division, I always believed in two things. One is, how do I build a reliability of a airline? It keeps flying for hours, and and we are always feel very safe flying. Hardly any incidents, very very minuscule number. And also, how do you bring an integrity of an oil and gas? So fundamentally, these are the two areas which always pulls me. I think through, and how do we achieve highest level of reliability as far as asset management framework is concerned for any organization. And of course, in a steel industry, which is heavily capital intensive, and also the processes are very hazardous. You have multiple operations, multiple engagements, a lot of interactions, interfaces. It's very important that we understand all the aspects of the steel industry, the various hazards, and how do we, work towards ensuring that all these aspects are taken care of so that you have a very reliable and a safe operation of the plant. With this, I just thought that it would be apt to choose this topic where over the years in our safety excellence journey, we have been doing a lot of work on various aspects of safety management. And I believe we have traveled quite a distance, but as we all know, the journey never ends. It is a continual journey. You always have to beat your own targets and take up new challenges going forward so that the workplace, both in terms of human and asset, becomes a highly reliable and safe place to work for. Because at the end of the day, we are all responsible for the people who work with us and see that when they come to the plant, they go back safely home. So that's the fundamentals. And that's where we need to see that our processes and equipment, everything is designed well. So can we move on, Rohit? So before I get into Tata Steel, while many of us who are from this part of the world might be knowing very well, and now a larger part of the world also knows us because we have grown quite big over the last many years beyond the country's boundaries, and we are present all over in the Southeast Asia. We are also present in Europe, be it the Netherlands, mainland Europe, or UK. So fundamentally, as you see, the Tata Steel Group. If you look at India, we began in Jamshedpur, and we have been growing organically and I mean through brownfield projects, and some from 3 million to 5 million to 7.5 and now 10 million crude steel, I mean, 11 million hot metal. And we also have a greenfield project which is Kalinganagar, which is currently 3 million ton, and we are now planning to move forward with the cold rolling mill coming up, and pelletizing plant and other facilities are on the anvil. Also, some inorganic acquisitions through the our TSBSL, which is the Bhushan Steel Limited Earthswile Angul plant, and Earthswile Usha Martin Tata Steel Long Product, that is TSLPL. That makes overall the Tata Steel India. And when we talk of currently Avelis, the Southeast Asia comprised of Thailand, also Singapore. But National Holdings, we have recently demerged, so currently we are left with Thailand. And when we come to Europe, we have Netherlands and UK. And these are the footprints in terms of our manufacturing premises and also the various distribution and commercial centers across the globe. And we are around 28.5 million tons deliveries, perhaps one of the 12 largest steel producer, and we have a raw materials division which comprises of Novamundi, Joda, Katamati, and Konbon, which takes care of the iron ore and the coal mines, primarily West Bokaro, which is open cast, Jamadoa is underground mining, and there are some lot of downstream facilities, cut to length, and the coal rolling mill facilities, the wire drawing facilities, and all. So, in a nutshell, this is the presence of a Tata Steel Group worldwide, and we have been able to brand many of our products, be it the structurer, which is for our tubes division, the galvanized cold rolling sheet Galvano, we have the Tata pipes, we have Tata Astrum, we have Varon for the wire rod mill, we have Tata Shakti, and so on and so forth, and Tata Stellanium. So this, in a nutshell, talks about our presence in the entire, all over the world. Yeah, Rohit? So from a Tata Steel scenario, when I come down to, where do we have a presence across? Shared service divisions, when we talk about, is all about the asset management, which is the electrical, mechanical maintenance of all the assets, right from the iron ore, from the sinter plants to the blast furnaces, pelletizing, the coke plant. As you see, we have a red box, dotted box. That's a presence all over, right from the hot metal area to the coke plant. Then we have a steel making and the lime plant area. And then once we have two streams of flat products and long cold rolling mill and long products we have. So primarily we are more FP based. We are largely present in the flat product because our Kalinganagar and the Angul facilities are largely flat products, mostly flat products. In fact, Jamshedpur has a mix of flat products, which HR coils and the cold roll strips and sheets, and also the long product wire rods. So this is how we are present across, right from, and I look after the Jamshedpur unit, which is the shared services, which takes care of, we have the asset management. Today, in the age of digitalization, it's important that you keeping pace with the scenario. We need to see how can we build our assets with the industry 4.0 and have more and more predictive in our maintenance journey. We have been fundamentally, we have moved with the erstwhile over the years from a preventive maintenance to more of condition based maintenance. Then from the past learnings, we were on a time based maintenance, that you keep changing things before a particular item wears out, or fails based on your root cause analysis, and you avoid a failure or an outage. But in the current scenario, as it is very competitive, and to remain, have a proper presence, where we thought that we need to, it's time that we take advantage of the current digital ecosystem that is getting developed or that is there. How can we move to a regime of predictive maintenance? So you get to do the maintenance when it actually comes into. So fundamentally, I have always been fascinated with. I keep sharing the Google car, which is a very intelligent car, which has its interoperability. It has its own self diagnostics. It has able to maneuver, and also how do I pick up those thoughts and build an intelligent asset, and how do I identify the critical assets, and based on that, we balance out. It cannot be all predictive because there's a lack of equipment in a steel plant. So you need to pick up the acritical or supercritical items where a breakdown or an outage can cause a complete disruption of the value chain. So there we need to see how do we build a predictive and have a good balance of predictive time-based maintenance, and also condition-based maintenance. So that's how, and future lies in being perspective. You keep learning from this, update your models, and then it will throw you insights what to do, and if certain thing is going wrong, you get an early warning indicator, and then based on that, you trigger actions so that you have the right action at the right time, which helps to have a higher operating hours and also optimizing on the cost of maintenance, asset management. So that's all about asset diagnostic center which we build, and we pull in lot many critical data centrally and then monitor them and send inputs to the line managers to take action at the right time. We also look after the power generation, distribution, the gas network, the byproduct gas, the BF gas, the LD gas, the CO gas, and all. How do we distribute in the reheating furnace and other areas? The plant, effectively, the Jamshedpur plant is 114 years old, right? Many assets are old, may not be as old now because we have been changing, but there are still many assets like the sinter plants, old, even some of the parts of coke plants and blast furnaces are still old. And we also have the newest asset like the TSL or the pellet plant and so on and so forth. So you need to have a good understanding of building and technological structures so that the reliability is maintained. We have utility systems, a huge network of rail and road logistics, which has to ensure that material movement, be it the hot metal, finished goods, or mostly hot metal and finished goods and raw material with the conveying system is there. We also have to ensure that the quality of product which comes out of the mill is the highest standard. A lot of technology support is provided across the sites, and also we have to have a very effective shutdown planning and management so that when we take a plant down, we utilize it and ensure that it comes up with the optimal time, and when it comes up, it runs up smooth and there is no failure after a shutdown or there are no interruptions. Yeah. Next. Right. So, just to in a nutshell, when we talk of asset management, these are some of the various areas, focus areas, be it shutdown management, spare management. I think these are all common for most of the equipments or any plant per se, be it a steel plant or any other chemical or oil and gas or whatever. So fundamentally, all the when you talk of asset management framework, it's all about this. But finally, what is important, as I said, that we have to have injury-free steel. We should have zero harm. That's the fundamental objective. And how do we, while there are other aspects, availability, we have to have low rejections, as I said, less number of process interruptions, so you have more reliable operations. But at the end of the day, the, the key theme is how do we drive zero harm? And for that, I think it is important that we need to understand the various hazards, and then how do we devise systems, how do we engineer them, how do we bring in at the design stage so that the equipment or the operations are very safe, both in terms of process safety as well as workplace safety. So over to the next slide. So as I was saying, when you think of various hazards that you have in a steel plant, you have all of them. You think of them and it's there, be it a toxic or explosive gases. We handle a lot of hot metal and crude steel. So that could be a potential of fire, and hot metal handling is there. There are lot many numbers of high speed moving and rotating machinery. There is working at height, because the access is the steel plant. We have a lot of conveyors, and particularly when you talk of Jamshedpur, as we have grown over the years, there's a lot many pipelines. There are a lot of conveyor galleries which cross one after another. So that poses a lot of difficulty in having a proper access. So I will come to that when in the later, but we need to see how do we have proper access so that you get to know, you have better visibility and address them, instead of a situation where you don't see what is happening and there is some problem later on. There are issues of fire, electrical shock, in rail track movement, the slip, trip and fall, and exposure of to control. Okay. Next slide, please. One second, just a minute. Please bear with me. So when we look into the data, I think the one of the key important data is the lost time injury frequency trend. If you look into the trend over the last many years, as we grown over size and complexity and multi sites, we have been able to work in a way so that our LTFI are constantly reduced. The challenge is how do we bring it down further with more and more sites getting added up with the difference in the various aspects, the locational aspects and all. And also with a larger contractor base, how do we develop some more skilled based, knowledge based organization, future ready organization so that we can drive this even more passionately. Next. So coming back to shared services, as you know, if you look at the Bradley curve, it talks about various processes. That is, where are you? Are reactive? Are you dependent? Are you independent? Or you are interdependent? And finally, objective is to achieve a zero harm. So as we moved up the ladder in our safety journey, so we obviously at some point of time, a couple of years back, definitely we were more in reactive than we had. A lot of focus has been brought in on safety audits and low risk perceptions and such things. And gradually we moved from a dependent to we're closer to an independent. And how do we achieve more and applying all such initiatives as we have mentioned, be it the PSSR or developing new standards, training people, having digital modules on e-learning, ensuring compliance and also deployment at site, standardization of work across tools and tackles. And now we are trying to see how do we improve our risk perception on a job, be it a shutdown or any job, and how do we address the risk, learn from incidents across, and also constantly make system more stronger. And through our CoE, the Center of Excellence, which we have picked up many departments, and driving safety with a lot of passion and commitment. And finally, as we see that with the strong digitization and a digital ecosystem that is around, we should be able to take advantage of the newer technologies, which will help to identify, be more proactive, identify the issues, the hazards, and create early warning indicators so that we will be able to drive safety and also create a culture which is more self-driven. And that's where our objective is: how do we move from an independent to an interdependent regime? Coming back to shared services, if you look at the data, of course, there are some. There we have been because it's so complex, and it is so different. A maintenance aspect in a blast furnace is slightly different compared to a coke plant, to a cinder plant, to a cold rolling mill, or the hazard level, the understanding, the process knowledge, everything changes. There's a lot of under. So you need to train people and develop them so that they understand the issues or the nuances of such a process. And so we have been driving many initiatives which you can see, be it the model workplace, or we have been focusing on contractor safety management. Very important thing is how do we have a better control on interlock management or process safety management. The MOC, a lot of changes happen. You need to document and control and evaluate that if you make this change, what could be the impact? What is the impact of that? Do I have a control? Do I have a barrier to ensure? Do I have a better visibility for monitoring? And likewise, this was some of the initiative in the early years. Then we thought that how do we ensure that people who work with us are trained? We developed the star rating standards, and based on that, we have been identifying, evaluating the contractors, their people, based on their knowledge, their safety deployment at site, from a 3-star to 4-star, and obviously the 5-star rating. So more objective is gradually move up the ladder towards 4 and 5-star. And as I said, the structure integrity is very important because the plant is a mix of old and new. So you have to have different maintenance strategies, the areas, particularly in centers and all, have a lot of dust deposits. You have to see that you clean it up and do a proper inspection. You have a lot of corrosion in the coke plant area. So that's the bigger the any steel plant. I think corrosion and erosion. These are the two key areas which keeps bothering any maintenance guy. So we need to work on material science. We allow working with alternate material, be it the fiber reinforced plastic or glass GRP, the glass reinforced, and also a lot of areas. How do we use graphene and all, which will help to give higher wear resistance, durability, and also it helps in corrosion resistance in a highly in an atmosphere or an area of environment which is highly corrosive and moisture driven. So and also we have been working on model shutdowns, the risk assessments I've already talked about, and a lot of emphasis has been given over the years on energy isolation. This is very important. If you are unable to isolate and lock the energy, be the energy in terms of electrical energy, you call it in the kinetic or potential, whatever. So we need to ensure that when a job is done on equipment, it is free from any hazard. It is completely isolated from the energy source. That's where we took a lot of campaign on energy isolation. I believe it is one of the benchmark which we have, the way we practice, and also on the confined space, on the understanding of all the red SOPs, as I already said before. Also the gas related incidences which keeps learning, and also it's important that you learn from others while you constantly develop your own standards, processes, systems. But it is important to look around, learn from not only from other steel industry but also different industry. There could be a huge amount of learning which you can pick up and see whether it applies in your area of work, and if it's so, then look back and how do you strengthen your processes and systems and SOP so that it becomes even more robust. So fundamentally, the focus in our maintenance area is process safety, of course, because you have many equipments and processes. You have to focus on structural integrity. Gas and electrical fire is another concern area. Not only electrical fire, I think any fire is a concern area because it might lead to electrical fire or something of that sort, but the reasons might be different. The other area is, unlike many of the European countries, the level of how do we train people more so that the understanding improves, the man-machine interface. How do we ensure that you have minimum MMI, that is man-machine interface? And fundamentally, how do you correct the human behavior? That means you need to ensure that you behave the same way when you are outside at your workplace, at home, or in a different environment. And when you come back to the plant, you follow some norms. When you go back, your mental state continues to remain in the same set of control so that you behave, you work the talk. I mean, what you say, you do. So that's the large area where we have to work further on human behaviors. Yeah. So when we talk of the process safety, I think this is a framework which we normally use. I think many of the industries use it. So now, three fundamental questions is very important. One is, do we know what can go wrong? That means, have we understood the process well? Have we understood that comprises of step 1 to 6? I mean, what are the high hazard facilities? First of all, how do you prioritize them? How do you categorize the processes as high hazard operation and low hazard operation? And also uh, develop the PSI inputs, which is process safety information development, PSID, and then identify the hazards, evaluate them on its merit, on the consequence and the risk. How do you mitigate that and do a project header study? So that's, once we know what can go wrong, then we need to see that if something goes wrong, do we have the wherewithal to control? Do we have adequate barriers designed so that it doesn't go wrong? Right? So, for that, we need to identify the barriers through a properly process, which is a bow tie analysis. And then we do the LOPA, which is, layer of protective analysis. We do the LR. These are all short forms. I put it down. There are various processes which we use to identify. And then when you have come out with this, you have identified your C4 and C5 consequences. C4 is it can have one fatality or highest consequence. C5 can have multiple consequences, severe consequences, multiple. So now, when you have that, there could be two things. One is that is your equipment well designed so that it takes care of such thing, which is through the process safety critical equipments. You identify in the entire value chain which are the key equipments which are you identify or tag them as process safety critical equipment. And other is that which are your process safety critical tasks. So one is related to asset, other is related to designing an operation philosophy and control, which will ensure through proper operation inputs, through training, through interaction with the employees to develop the competency of both the employees and as well as the contractors. That is one part of it. The other part is that how can I design, as I said in the beginning, that you need to engineer safety. You need to ensure that we design safety at the initial stage, from the learnings and from the analysis or from the understanding of the entire process, that what all needs to be done at the early stage we should do. So having done this too, and we know that, as I said, answering the question three, that do we know whether our barriers are effective and working properly? Because when an incident happens, it should be able to control and minimize the consequences. So that's where the assurance part comes from. From one part is from the asset management framework, the design and maintenance quality assurance. Other is on the operation control. Once you do this, then you are able to reduce your risk. You are prepared with your emergency preparedness so that you know if something happens, barriers are there to control, but you need to intervene and understand the interfaces and manage well, and you have better control. And to see that the system is in place, you have audits and such things. And and if there is a change, the management of change has to be done from time to time to ensure that we constantly revisit, and during the process something happens and you find that something is missed, or you need to refine that process, or you need to strengthen the process. So you have to have a management of change. Over and above the, it is all important that the leadership and commitment is very important. That encompasses and engulfs everything. If that is not there, nothing is going to happen. So it is very important. That's we have been practicing very high. So we call it as a CoE model for process safety implementation. Yeah. Next. So I will not go into all these details. There are a lot many initiatives part of it to make it digital and make it smart. So like we need to, first of all, how do I have a close connect with understanding the process safety critical parameters and critical, yeah, how do I have a review? Everything should be in a SAP based system so that you get the right trigger the right time. You the entire repository of the contractor work person, also our people, uh, be it their history, their safety, all such things. How do I monitor and keep it as part of is there is a CLM system, and it also important not only from a safety point of view, but as we have digitized the entire works permit system, which is the e-permit now. So initially it used to be a manual. There are also three forms. People used to fill it up manually, fill not very clear, then run around from one place to other to catch hold of the person to give a clearance and all this. So a lot of time was getting lost, and also we were unable to have a better control. So we thought that why not? This again learning from some other industry. We said why not build an e-permit system where everything is properly documented. You can retrieve, you can connect, and it is very easy for the entire permit system to move from one person to the next person and comes back, so that in no time. Of course, you have to be at the site to do the physical work, but your document movement, that sort of activity takes quite a bit of time, and we have seen we are able to save some initial, because on a shutdown day or any activity you need to have a permit. No job is done without a permit. So this digitization have making the permit smart has also improved our effectiveness on productivity, on doing the job faster and better, and also visibility that you can connect. And with this, if you can tag the people who are working tomorrow, you can always say, okay, this particular equipment, these are the people who have been working, they have been trained. How do I ensure that for similar jobs within the plants or a different, I can pull up the same data, I can pull up the same set of people to work. And why through a single gate pass system, people can move from one pass to another. The GDCS is a very important aspect where we have a entire document control system where all SOPs, all standards, everything is present, is there, and you can just with a click of a mouse or with a tap, you are able to visible see it in the site and need not be running through pages to see through it. And as I talked about, fundamentally everything is built on a SOP based, and how do we standardize and learn, and how do we cross calibrate the risks and from similar facilities and continuously ensure that the processes become more robust and more better to monitor and more controllable. So at the helm of everything, it is very important that you have a good set of people who understands. And I've always believed, and I think all of us believe, that if you have a good understanding of the process, you have been trained well. Of course, if you know the equipment well, you will definitely know the hazards better. And once you know the hazards better, you will appreciate the risk associated with it, and you will definitely not like to take a shortcuts. Many of the incidents happens all over the world when people take a detour, that they do the way which is not mentioned, or do try to take a shortcut to save some time. Many, most often than not, they might be doing it, but on one find, when every with a Murphy's try, when everything falls, not in falls, four or five things doesn't fall in place, you land up in a serious injury. So it's important that people appreciate. So a lot of stress has been given on training. How do we train the people? And also, it's not only classroom training, it is also about how do we convert those into more actionable learning, so that we identify the people, we identify the assets. How do we also build the learnings on past failures and areas where people try to understand that this time they have to do this in a different way. And we have built various school of excellence, fundamentally on many aspects of the trades, be it mechanical, electrical, or processes. And we have been identifying people, mapping them, and training them, and we are monitoring on the whole quadrant how are they getting trained. And then it's not only training; we also need to understand, have they understood what we have been training. So it's important that we need to certify. There are various standards. We have silver, gold, and platinum standards, and the objective is that more and more people have to be more platinum standard, that is the highest, so that they understand the safety, they understand the equipment, their performance will improve. If you are better trained, if you are knowledgeable, if you are have the expertise, then definitely your productivity also will improve, which in any way helps to improve the maintenance effectiveness and reliability of a plant. So these are on the right hand side. You can see many such initiatives, be it various. We have digitized many of our training tracks. We have been able to build some simulators, which helps to interact, make it more interactive, and see how to, also like emergency response and all. How do we make through remote control, have everything visible at the control center, the action, the person who controls the whole area. So many such initiatives we are trying to take, build analytics on that, and see that how we can make our assets more predictive, and of course, as I said in the beginning, more prescriptive. Yeah, coming back to workplace safety, there are, as I was already talking about, that we have been driving the CoE, the Center of Excellence, various departments. So fundamentally, from a now, when I'm talking from a maintenance standpoint, it's very important that you know your PNID. That's the basic. How well, and if there are some modification changes, it keeps happening everywhere, all over the place, everywhere. I think so. You need to have a good understanding of the MOCs, the changes. How do we update your PNID and have a good control? How do you understand and manage the process safety critical equipments? And also device systems of testing the lot many of the safety relief and other valves, vessel storage and all, which normally how do we do it online? And a lot of work is going on. We are trying to make it innovative, of course, ensuring that we stick to the safety standards and have a very strict access control through better barrier management, through better what do you call it, the guarding of all the conveying system or all critical assets. We the pandemic also helped in a big way to do things differently, which otherwise we wouldn't have done. When things were not happening, people were not allowed, the experts couldn't come, travel was not happening. So we need to find out ways and means that how you continue with the same level of activities while you do not have the right resource or the expert present at site. So we took a lot of the cameras by panning and zooming, extending the insights from the workplace to the distant monitoring center through video streaming and giving the control to the person sitting out there so that he could see, maneuver, and guide. So this has helped, and today it has become a way of life for many industries, and we have taken a good. I mean, this has we have built on that going forward. Lot many inspections, lot many activities which are not accessible. Through this, we have through video analytics and cameras, we are able to control many of the critical jobs, and also it helps to improve safety. Uh, then we said we positive isolation is very important. Of course, many a time people you normally log out, you tag out, but it's also important to see that if you have logged out and tagged it equipment that this has been isolated, has it really happened? So the concept from a LOTO, we are now working more on a LOTO. That means log out, tag out, try out. Try out will ensure that absolutely, if you think it is positively isolated, but we've ensured that yes, it is positively isolated. So a lot of stress is put. Now, how do we drive this concept, the culture of LOTO across the organization? And of course, more and more SOPs we want to make it through the digitally how to convert them to simplify them and make it readily available to our people, so that at the whenever you need it, you don't have to rush all the way back and run through tons and tons of paper, but you have it. Everything is digitized, and you have it in your systems so that you can easily go and check. And so that's the audiovisual SOPs on the e-learning platform. And there is we use lot many safety access systems, and we are constantly trying to innovate and see how we can inspect through remote monitoring, through better access, and through live streaming, and so on and so forth, and use more and more augmented reality where the expert sits far off and somebody goes on with a helmet on the camera fitted, and then you get to know the conditions, and you can always give an advice to the concerned person who is actually on the work. So these are all initiatives which we are taking to make the whole process smart, and definitely in that it will definitely help to ensure safety, and also I believe the maintenance effectiveness increases multifold. If you do a safe execution, many people think that okay, if you do all these things, you will lose time. But in reality, if you do things right as documented in the way we are to do, it eases out lot many complexities. It helps to execute the work more faster and better. Definitely better. So coming to the next slide. So I would like to stress upon this positive isolations implementation initiatives which we took many years back, and I think we are proud to show that we have been strengthening the system, and it's a benchmark level. Lot many activities be it electrical isolation. As you can see, some of the snaps, we put it across so that you can appreciate the fluid. A lot of valves needs to be isolated and locked so that nobody can operate while some work is going on or by mistake. So these are isolation of valves, isolation of circuit breakers. Even on a track line, when you're doing some track line maintenance, you have to ensure that nothing comes in between. So you have there are multiple examples. I just picked up a couple of them, for just to show that how we are driving this. And we have this lock system where we have developed. Originally, this equipment never came with all these mechanisms, so we have built on them how to develop locking mechanism, and we use various types of lock. The red lock, the blue lock is used by the contractor supervisor. The red lock is used by the employees, and the person is isolating it is employing yellow lock. So these are various types of locks which we actively use, and no job will happen unless these things are strictly followed. So that's about the positive isolation initiatives, which has gone a big way and is standardized across the organization. Another thing is important, as I talked about management of change. You know, many times you need to, I mean, do some, there's a need of the hour that you need to put a jumper, or you need to isolate for time being, or uh, some failure happens, or you may have to temporarily bypass or force an interlock. But many a times it happens that you if it is all manual, you may forget, or there is no trigger, there is no monitoring. So we took up the initiative that on SAP platform, how do we build a strong interlock management system through with the help of the digitized system, so that today everything, most of the department, is a drive initiative. Gradually we are migrating from a logbook based interlock management system to a SAP based system, which will one is that we have a standardized way of implementation. It improves the better visibility, and it also accountable. You know that who has done for how long, and if you have given that I will revive it in say 2 days. Obviously, the trigger will constantly come before the time comes, so that you are reminded that this has to be done. And how are you monitoring it? So the record monitoring or tracking of interlocks, visibility, everything is much more better. So this has in a long way ensures that your processes, your critical instruments are all under proper control and under strong vigilance. So that's us. We have implemented this across, and we are driving it so that we have a uniform application across all sites. Coming to the next slide, on as I talked about, every we have multiple standards, be it for confined space or positive isolation or convey standard or barricade standard, scaffolding standard. You name them, and we have developed standards that what should be the process, how it should be done. But what we are seeing that many when the incidents happened or some injuries used to happen, many there's a big knowing and doing gap. One is that first is the knowing gap. I'll talk. So there are standards, but we are seeing that maybe the people down below, who are the guys who are front ending the job, may not be aware. The awareness level was not that good. When we deep dived, we found out why. Because maybe they may not be. These are now simplified. They were not written in the language which is more understandable and more easy. So we took the initiative, we worked with Accenture, and we built this simplifications of the safety standards, where we developed the Googling facility that you don't need to run through pages to find something. You can just type it, it will take you to the relevant page so that you can go and then see. It is much more simplified, it is more visual, it is more pictorial with related photographs of the plant, so that a person when he goes through it can see that it is uh, you know uh, he can relate easily. So that's very important. And it is has been simplified the language from big paragraphs and multiple complex wording. We brought it into simple bullets and just step by step. So I believe this has helped a big way in improving the awareness, the knowing gap. Then comes the knowing doing. How do I minimize? So by providing more mobility, and then many of the standard we build some sort of storytelling to relate some incidents and then say that this is how it's more interactive so that people go through it. And also we wanted to ensure that when he goes to certain pages, he reads, he evaluated, then he moves to the next. It's not that he runs through the entire standard and then we try to evaluate. How do we do in steps so that we are sure that he has understood this? We gauge his level of his acumen or his the acceptance which has happened on the subject, and then move to the next step. So that's how I think a lot of initiatives over the last many years have been taken to simplify the safety standards. Not only simplification, but also make it easily accessible and available to people so that they can, through the GDCAs and all, they can see this the systems strongly standards so that when they need at the time of the job, they can easily refer. So this is definitely helping. Now we need to see how do we ensure that we have a uniform deployment, and we also uh, see that people understand and then do the job rightly as it is written in the SOP. There is no deviation. Next. So I am talking about various aspects. I talked about positive isolation and safety. There is a lot of work which has happened on confined space. That you work inside an area which is confined. How we have proper system, proper checking, and then providing. Providing clearance to work. So that is on confined space. Now coming to rail safety, uh, we keep moving a lot of material and also hot metal from one shop to others. So we have to ensure that we don't have minimum or eliminate the derailments. So a lot of digital initiatives have been taken up by diffuse sensors so that we can identify and with early warning signals we are able to identify and take control. We are also using smart solar signaling system. We are just all proof of concept which we are trying out to ease maintenance and ensure that the maintenance is more reliable. And laser-based systems are also used. And now we need to also see how do we have a good visual inspection of the tracks. So which we use the semi-automatic track inspection vehicle, and also UT is done for all the rail tracks so that we are able to identify any defects. Or this is a technology which we are using. I think it's many of you must be doing all over, but I think we are extensively doing this and ensuring that we identify if there are some premature cracks or something which can lead to any failure. How do I identify them early and replace them in a timely manner so that we have a reliable rail tracks across. So this is related to rail safety. On the road also, we have been, for many times these zebra crossings are not visible. So we have put this new technology of a visual display which glows, and then it helps to the LEDs, and which helps to the simple things. But the small things helps to make all the aspects much more better. Then rubberizing on the level crossing, you keep people stumble, fall, and skidding happens on all these places. How do we ensure that we minimize that risk through better rubberizing these areas, and which also acts as a cushioning and also helps in better seamless movement across. Then the not many structures we have seen that sometimes the moving dumpers and all also hit that might damage. So we use the barriers which prevents fouling of vehicle either with the overhead electrics line or any of the structures which can lead to any failure. So these are the simple things but very important and very effective in managing safe movement of goods and material across the plant. And this example of before and after, like how we have you can see we have put some of the Um, I mean, the rail routing some of the solid rails, which acts as a protective, so that on the turnings, many a times or at the odd hours, the people because of some dizziness, something, a moving vehicle or a heavy vehicle can go and hit and damage the whole structure. So these are some of the protective devices, fundamentals which has been done to ensure that we take care of the blind spots for the driver. Working at height is extremely important, particularly in a steel plant and many industries. So we do not do any work without a scaffolding, even if it is a 1 meter or whatever is the height. So and with proper harness and all is ensured, proper audits are done. The scaffolding is, but many a times what happens, you may have to do a job at a height which might have for a few hours, but it might take many days to make that scaffolding. So, how do we improve productivity in such cases? So, we brought in a new concept. It's not new, but it's new in the steel industry. Perhaps we are the first and pioneer. Like many things, we have been pioneering in steel industry and Tata Steel. This is also, I think, pioneered in the steel industry per se in India and definitely in the world also. The rope access mechanism technology is extensively used in mountaineering and also in the rigs, in the oil rigs which are in the midst of the ocean or the sea or the bay, where you cannot build a scaffolding, so you have to work on rope access. So this, once with the last couple of years, we have been able to access many such areas which were unable to reach out because of inaccessibility or because of no space to build a scaffolding or other ways coming hanging off from the top. So these are some of the areas working on the chimneys or in the big containers or holders. So many areas we have been able to take good help, and they are specialized vendors. We strongly say that they are IDATA certified. We only use IDATA certified, and today in our maintenance journey, as far as productivity is concerned, the rope access system helped us in a big way, and we constantly trying to identify more and more jobs which can be done reliably and safely and in the most optimal time without compromising a decimal on the safety in a much faster way. And this also helps to some places we cannot build a scaffolding, but this as technology. So it is a balancing of scaffolding and propex, and also lot many crawler type. Below the steel melting shops, you have issues. You cannot have normal vehicle going. So we have search for such machines which are basically like a tank crawler, and you have like a genie extension. So this is something which can work in any steel plant or any place where you have very undulated surface and completely rugged and not smooth at all. At the same time, you need to reach out. So this helps. And under deck of conveyors is uh, very difficult to access. So we are using this web catch below the conveyor decks, or per se it need not be convey any structure below a structure. You can hang this web net, web catch. There also, if you have to do some heavy work, you can have a web deck. You can hang like cantilevers, catenary, and then you can, I mean, from both sides you can put those platforms, hanging platforms, which we call a web deck, and people can safely work under the conveyor deck or under the any structure which is normally not accessible. And lot many height areas we have with the thermal imaging. Again, these are all technology, digital initiatives which is helping us to be more productive and faster. And thermal imaging for inspecting of the power lines, the power grid lines, and all. And also, we are trying to do in the next slide, please. We will show on the gas lines also. We are doing lot many work. So, as I said, structural integrity is very important for any steel plant. And we have the building structures, which are the plant and building. We have the technological structures like the conveyor galleries, the bunkers, gas pipes, and so on and so forth. And then over and above, we have the gas line inspections. So integrity, mechanical integrity, be it asset integrity in terms of equipment or in terms of a structural or civil, The very important aspect for any asset. So we need to have a strong regime on inspection. That is fundamental because you have to do your basics. Have a very strong physical inspection, and then you work on, I mean, on how do we pick them those insights and build analytics on that. We have been able to model them those failures, and then tomorrow you can compare. You pick up a photograph and it will say that this is the photograph, then these are the likely defects. That's we brought in some digital initiative in developing good models for identifying the I mean this the structural defects or such defects, and so that any person can understand that if this is the type of defect, this would be possible cause, and you need to act upon. It's like try to move fast. I think already we have crossed 1 hour. Rohit, so I have talked about maybe drones we use a little bit to look into the access areas, do the chimneys, entities. As I already talked about the rope access system. We have also tried to monitor the structural condition because the structures are normally static. So apart from the inspection, we also use the FBG strain. We have started to use and monitor the deformation or the movement of the structures and try to see that when can we address them. The FBG, these are strain gauges, some special optical based strain gauges which we are using, which helps us to identify some of the early deformation which is happening in a in a structure, maybe because of the excessive wind load or some corrosion or whatever thinning. So we have been trying this new technology in some areas, and which helps to identify at least the critical structures we have been trying to put in and try to develop some standards, and based on that we will be having a trigger points when to act on. So this is some digital initiatives on structures which we are doing. Slide. I have talked about it. The SFP, the LAM platform for gas line monitoring. The entire gas line of the plant runs into kilometers, is monitored in LLM, and all pipe condition. We do thermography, we do thickness monitoring. Also, how do we detect? There are special cameras which we use. FLIR cameras, which are infrared cameras used to identify CO. Normally, it is very difficult to identify if there is some CO leakage somewhere. So we extensively use this sort of a camera, which this is the output you can see on the right hand side, which gives a good view of the various leakages wherever is happening in the plant, and so that we can have a early uh, warning indicator and take action to correct them at the earliest opportunity. Next. So fire safety, these are the data. Over the years we have worked quite a bit, and you can see the numbers have drastically come down for good, and we have few cases, but basic is that you have to ensure that the safety is a proper health and hygiene of the equipment should be there, proper cleaning should be there, and over and above we are using some infrared cameras to identify if at the early stage if a fire happens, how do you pick them early so that you douse them at the earliest opportunity. Next. So I will run through this. I will not explain because of paucity of time. These are some of the initiatives which we have taken to control the electrical or fire safety, be it by encapsulation of the hot metal areas or nitrogen-based fire suppression system, and also the taking an advantage of various technological advancements and available knowledge, we have been able to, control electrical safety, fire safety. Next. So let's move on. I think I've talked about it. In the AC also we have identified. So if there is some incident, we try to pick up some learnings from there, and then how do we standardize that learning across? We have developed good e-learning modules on fire safety, on electrical fire safety, some quizzes to understand the knowledge. Digital intervention for foolproofing. So, this is something, the e-permit will not be issued if you are not worn the proper PP. So you have to, the guy who will, permit will only be issued when a proper photograph of the person wearing the PPE is put, that comes along with the permit. The person sees that yes, he has worn it, then only the permit is given. So this is how do we take advantage of various technology, digital video analytics to control the behavior of a person so that he's forced to wear it, and then by that process you are controlling his safety situation. Yeah. So sensorization and digitalization, we talked about how do we work on the Lototo concept. I talked about sensorizing the all the key parameters, and you move out far away from the equipment and monitor it centrally at a AMDC, so that all the online data is picked up, and we take that feed forward, and then uh, controlling of if some parameter is not okay, we work on that. So by this you are moving far away, we are able to, one is that it is much more faster, it is more online, which anyway helps to be more effective. At the same time you are ensuring that people, you are creating a proper safe distance for any person to, so that there is no incident. So this is all about some of the sensorization which is happening all across. We have picked up the various equipments, and then we are building around that the analytics and control models. The conveyor guarding, many a times what happens, you do a work and you don't put a conveyor. So we are able to digitalize this conveyor guarding, smart conveyor guarding system, so that if you remove it, any of the guards, and if you don't put it, the conveyor will not start. So this is another initiative we have been taking and identifying them and picking up. Yeah. Next. So we have talked about this earlier. Remote operation of on the rack in, rack out for all the various electrical installations, and wearing of full coat and monitoring from far off. We are able to do that. You can see before and after photograph. Next. So again, the hands are not tools. This is an initiative where we have been trying to identify various initiatives in the plant where we can, by mechanization, by proper small initiatives, by engineering the solutions, we have been able to save access of the hand or the limbs can be eliminated, so that you can avoid a safety incident. So these are some examples. There are numerous of them. I picked up a few of them just to give a glimpse of what is happening across. Nothing digital about it. But as I said, there are many jugards, many things. How do we design them, engineer it properly so that that becomes a standardized way? And then we are trying to work on a standardized tools and tackles that if this has to be done, it has to be done this way only. This is the initiative of standardizing all the various, so-called, improvement initiatives which are converted into standard designs in terms of where you check into all aspects, the safety, the integrity, and its robustness. So that's all about some of the mechanization initiatives. Next. Again, few examples of, I think many of you must be acquainted with this, but there are few of them, and there are numerous such examples across in any industry. But we are trying to capture all of them and put them in a proper standard and see that any job of this nature is only done this way, so that you completely avoid any hazard related to any incident related to something not being done properly in the right manner. Next. So lastly, when we talked about smart maintenance, which primarily intelligent maintenance, is built on all these platform fundamentally on a SAVPM base. And I have been talking about it during the course of presentation on the shutdown monitoring, digital CLM, contractor labor management, be it spare tracking or real-time resource availability. The mobility solution that, the person at the workplace has the progress report, he has everything on his laptop or is in his mobile, a tab. and it helps to work much more effectively. The drawing management, interlock management, all such things helps in developing to connect. So fundamentally, it is connected people, connected plant and process, and connected assets. So the three P's, which helps to ensure that we maintain the assets at the highest level of reliability and safety. La- Lastly, uh, going forward, as we are driving to become more and more future ready, and digital and technology will be the way of life. And at Tata Steel, I think we have been driving quite passionately, and we have seen that during the pandemic, it has definitely helped a big way. We were ahead of others, perhaps, in many of the initiatives, which further got hastened up or expedited because of the need of the hour. But as I said, going forward, how we can be more and more proactive, how do we can use technological interventions to improve the human behavior through AI, artificial intelligence based PP monitoring and system, identifying the violations of not holding the handrails or walking on talking on the mobile while climbing the steps. So many such things keep happening. How do you pick them? Because a lot of cameras all across. How do you pick the feed, work on them, and reach out to the people and say, hey, you are not doing the right thing. So more and more you reach out to people, the message will be very, the culturally you will understand that this is how we have to. So once you know you are monitored, you are viewed, obviously the behavior aspect will also improve. And like what is you seen in green dots is already in the place. We are now trying to also capture through image processing which is the right place, where not to go, and all such things. How do we engineer solutions so that we have improved, and of course work towards process safety, reducing process safety incidents. We talked about, we have already task force, we are working on identifying such incidents and how do we look back from the past learnings and ensure that those are built in our systems. So this in a nutshell, I just wanted to capture the entire journey of our maintenance safety journey in the area of shared services. It's all across the plant, but while I'm talking fundamentally mostly on maintenance, but it is a standardized approach across the organization. I believe this will definitely help to take our safety journey to the next level. Thank you. I think I took some additional time, but the subject is so vast. So for 15 minutes of your time
No,
more,
no, no. You have not taken any additional time. You spared your valuable time, Prabal. Okay,
so
mom.
so fundamentally, our motto is be safe. In the age of digital system, industry 4.0, you need to be swift and smart. And of course, whatever you do has to be reliable and sustainable. You cannot do once and then be done with it. Every process, every system has to be seen as an irreversible process. It should be sustainable. So that's it. Have a safe, swift, smart, and sustainable industry shared services on a 4.0 platform. Of course, idea is to continue to deliver value and create a strong, culture of safety wherever we work. Thank you for giving this opportunity. I hope I've been able to be explicit enough to people who belong from the steel industry. Maybe may be able to relate better, perhaps. But most of the examples were most try to be very simple. But I picked up many examples when you can try out in all areas. You can reach out to us. We are there to help you out wherever necessary. And of course, the initiative by IIT Kharagpur, uh, Professor Krishna, Ovi Krishna, Professor Maiti, and the entire team, I think has been doing a fabulous, drive to take it to a next level. Said we need to design it well so that it becomes a way of life. Thank you. Thank you.
Con-
So, lots with these illustrations and the examples that have been deployed in the shop floor, and that too coming out from an industry expert like you, I think it again re-strengthens our two beliefs. One is good safety is definitely good business, and of course, all injuries and accidents can be prevented and must be prevented. So, sir, there is a storm of questions in the chat box, and a few we have received on WhatsApp also. So, I'll be initiating the Q&A session, sir. So the first question is, how can we predict failures by personnel in carrying out the safety critical tasks which form barriers in the bow tie?
Come again, please. I just missed it.
Sir, how can we predict failures by personnel in carrying out the safety critical tasks which form barriers in the bow tie?
So, as we said that first of all, safety critical equipments, we need to identify them. Then there are a set of processes, some checks. Of course, some are built based on the various schedules and frequencies, but some through digital initiatives also we have been able to pick if some threads are there, which can give some early indicator. We will be able to, take our initiative. I mean, what do you call it? Or interact, not interaction. I said you can take a action well in advance so that you can avoid a potential failure. So wherever it is possible to digitize the inputs, or I mean some of the by sensorizing or picking up the parameters and monitoring them on a real time basis, you can have a good understanding of the trend. And then if there is some delta change, because when it comes to a situation which is an alarm, it's too late perhaps. The whole objective is that how can I have an early alert? And I can play on the alert to alarm gap so that early I identify them, I take a corrective action. My interest, how can then address that equipment or a piece of equipment or an instrument so that I avoid a failure. So that's how I think through predictive aspects we can develop a stronger and reliable barrier management system.
Thank you, sir. I would request Sovik to take forward the next questions, please.
Yes, ma'am. Thank you, ma'am. So, sir, the next question is that what is tryout in positive energy isolation?
See, like many a times, I'll give an example. Suppose you have two conveyors, for example, right? And from a live practical example, and two conveyors are identical, or maybe you have barrage of three conveyors, right? At some many of times it happens. It is quite common that maybe one is running or two are running, one standby, and keep changing. And suppose you have to work on one item. So how do you ensure that the right, and obviously when you it might happen that you isolated and the wrong one has got isolated. It can happen. So how do you ensure that the item where you want to work, the equipment on which you want to work, or say for example in this, if you have three conveyors identical, or many a times the numbers are there, but how to foolproof it? So when you isolate it, you also try out. You log it, log out. You tag it out that this conveyor is down, but really the item which you have, the conveyor where you tagged it, that this will be the conveyor which has gone down, is the right one which has been power source has been identified. It's better that you try it out and see if it's not moving. Then you're sure that yes, the right conveyor amongst the three has been isolated properly. So that's where that Lotto say we are now driving to Lotto toe, that try out also wherever possible. So and many of the times you think through, it is possible to try out and see that have you identified the right equipment, or have you isolated the equipment correctly. So that's the concept of Lotto toe. It's simple, fundamental. It's only you need to take some time to do that. So we worked on that, and I think in many of the shutdowns recently, we are trying to drive that. And you try it out and you put a log that, yes, I have tried that out. And you ensure, then the person is working is very confident that, yes, this is totally isolated. So this eliminates the slightest opportunity of a mistake. Okay. Because
Yes, sir.
mistakes
Yes,
could
sir.
be very, dangerous, and you can lose a life or whatever. So it's always better to ensure, and then the responsibility I give it over to Midu for maintenance or whatever, any intervention.
Yes, sir. Thank you, sir. Thank you, sir, for your lucid explanation. Now, sir, I am taking the last question. So it is saying that in case of an emergency, is there any mean to virtually inform every personnel for evacuation?
So it all depends on where, of course, when we today There are processes, there are with the people all have smartphones and all, you can always relate and inform, but if you see, when you're talking of, are you talking of the entire plant or you're talking of a specific area? Obviously it can be possible. And the entire emergency, we have a emergency preparedness system where we are monitoring the entire processors. It could be gas exposure, it could be anything. So thus can be definitely identified and communicated. You have a mass mailer system. The relevant people get information. They get together and they control the entire scenario. So it's possible. It all depends.
Yes, sir. Thank you, sir. Now I would like to invite Professor Krishna to formally provide you the vote of thanks, sir.
Okay, okay. Prabal, this is Tata Steel, and Tata Steel is Tata Steel. So everything happens by design.
Yeah.
Everything happens by designing out the hazards. And I'm confused. How can I thank you? The way you narrated the whole of the things, you're not left out anything. This is the real digitalized safety management system. Uh, how many things you have shown? How many improvements you have cited? People, if they take any area of people working, they can use the relevant improvements which you have
Yeah.
brought in. And how you have taken out the people from the hazardous places by automation, that breaker raking out from remote areas, using drones, using IIoTs, Industry 4.0. What is that? You're not left out anything. And I'm amazed. My alma mater, Tata Steel, the things are happening like this. And the whole world who is looking after this, they can take this improvement there to their home. Let me also tell you the present the present occupational safety, health and working conditions code 2020, which is going to be implemented shortly, talked about all advanced systems, the digitization and all those things, contract management, what they put the things in the digitalized form, all those things Tata Steel have done already at that place. So implementation of the recent code is very, very easy for you. Uh, and the implementation, what you have done is the example how to implement the new code 2020. I'm very happy that Tata Steel is already, as they are always proactive, they are also proactive in thinking what should come in the management system, and you have done very, very nice, very nice. The automate, the drones which you are using, the rope access systems, all those things. What you have brought really technology into the safety management. You are addressing the hazards through technology, very less through human people. That is what the research says. The research says to not much depend on the behavioral based safety. You have to switch on to engineering safety. 70 to 80% of the hazards could be addressed. That's what exactly you have shown. Most of the things you have engineered the hazards, and the prevention through design, what people thought, that is what you have implemented. Nice, Prabal. Your presentation is really nice. It has enthused the academicians. There's a lot of scope for academicians to work on different areas of research, taking the clue from the presentation of Prabal Ghosh. And nice. And actually, your talk should have been divided into 2-3 sessions. Then it could have been more justified the way you've shown. But however, you've packed it very well and you're really prepared. I'm thank you very much. Being a very senior executive of Tata Steel, you've put a lot of efforts to package all the things in a very right form. Professor Maiti, you want to say anything?
Obviously, I cannot resist myself without saying. So I can tell you, Mr. Ghosh, from your lecture, I have taken a lot many things. Many things you have presented which the center can look into and we will work on it. And it's an amazing lecture. I'm telling you, I have written almost all the points in my note. so that I will not forget what Professor Krishna already mentioned, the digitalization of safety, that from everything, every aspect's point of view, and within 1 hour. It's really amazing. I'm telling you, we are really owe to you that ultimately, definitely, your advice and what your presentation I'll give, and I will first show to my student, the researchers, that see, choose some areas for research, do some good work. So fantastic, Mr. Prabal Ghosh. Thank you so much.
Prabal, I have a request from our CoE, Center of Excellence in Safety Engineering and Analytics. You should always get associated with this academic institute,
Surely, sir.
with CoE. This will make you more energetic, and the CoE will also get more benefited. So we want to take your association whenever is required.
Definitely. And I think the organization Tata Steel will also get benefited with the association
Yeah,
with the learning
yeah.
institute.
One day we'll call Mr. Narendran when we make say 100 episodes. Then Mr. Narendran, person like Mr. Narendran will come and
And
he's aware of CoE. He's aware of CoE. I have expressed.
Professor Krishna, I think Professor Krishna, Mr. Ghosh will be a very good teacher.
No.
Yeah, I'm telling you. I hardly said, but those when I preach, I definitely reason I preach. And after all the things, with smooth flow. But as a academician, I was really amazed. I am just eagerly, just I can say, I am just eating everything what you have said today. Oh, so nice.
Okay.
My pleasure,
Yeah,
sir.
every good thing should come to an end. So I thank moderators, Mom, Savik, Ashish, and Sinjana who are on the background, and all the audience who are present, and you're supporting these things. I know the audience here, Prabal, they are all very serious audience.
Yes.
Just for participation, nobody will come. They are all in this business, and they come here to take the learnings from here. Thank you very much. Thank you all. Again, next week, next Friday, again at 8 p.m. we'll start with one more speaker. Thank you all.
Thank you.
Thank you. Thank you. Thank you. Good night, everybody. Good night to all the participants. Thank you very much.